Hey, Mr. Z, how are you?
Hey, how are you doing, Ms. Awad?
Good. So we're going to work on sedimentary rock identification and try to tie some things back into environments and structures when we see them, right?
Yeah, we are.
All right, where should we start?
All right, well, we should start over here with this diagram, and you're going to have this available to you in class when we do our rock identification lab. And the first thing that we want to talk about is just a quick recap of grain sizes. And we mentioned this in the video on sedimentary environments, but we're going to talk about it again here briefly because it plays a really important role in identifying sedimentary rocks.
So on this one we're talking about one of the groups of sedimentary rocks, which we're going to call either clastic, made of little clasts or sediment grains, or we're going to call it detrital. And I know I use those words interchangeably.
Sure.
I'm guessing that
well.
you do and Mr. Baldwin does as well. So if you hear us say clastic, we mean detrital, and if you hear us say detrital, we mean clastic, because they mean the same thing.
Exactly.
Okay, good.
And we're really just talking about sedimentary rocks. They are just pieces of other rocks that were cemented together, at least this form of them is, and then we just make a different rock from it. All right? So going back to the grain sizes, we start out with gravel-sized grains, which are the largest, or coarse grains, and then we make our way down through sand, silt, clay, and then all the way down to crystalline, which we'll get to in a later video. All right? The next thing that we want to talk about is the grain shape, all right, which is also really important. And here we talk about grains that are very kind of jagged. We refer to those as angular. All right, and then we go into kind of a little bit less angular. We start to see a little bit of rounded edges, but still somewhat angular. We call that subangular, and then we see grains that are starting to become a little bit more rounded as subrounded, and then finally we have no jagged edges at all, and everything is rounded off.
So as we're thinking about the energy of the environments, it takes energy to take a grain of sand or a piece of gravel and break the edges off it, break those angular edges, and make it go from being an angular grain, gradually chipping off those little angular pieces till it's nice and tumbled and rounded. And that would happen down the course of a stream.
Exactly.
Or that would happen from sloshing back and forth in the waves. All those kinds of higher energy environments are going to create the more rounded, well-worked sediment grains.
Exactly.
Okay, good.
Exactly. All right, and then again, another quick recap over here. This final is the grain arrangements that we also talked about in the first video, where we talk about something that is poorly sorted, which really is just a mixture of different size sediments. We have moderately sorted, which is a little bit well organized, and then we finally have well sorted, where everything is pretty much the same size.
Okay, so we're going to switch from this page in our lab book to thinking about how we're actually going to identify these rocks when we come across them, and then what we can learn from them once we've identified them.
Okay.
So we really have 3 steps in this process, right? We have the step where we're looking at the size and shape of the grains. We have the step where we're looking at the composition of those grains, whether it's gravel, whether it's quartz sand, whether there are other minerals mixed in with the quartz sand-sized grains, or whether it's a mud or clay. And then from there, we can pick out the rock name as step 3, right?
Exactly.
So you want to start with the coarse grain sediments?
Sure. So we're taking a look over here at just this top section of the rock identification chart, and we're all familiar with these. We did this for minerals and we did this for igneous rocks as well. So I'm going to go ahead and grab myself a rock sample over here. And if I take a look at it, I'm gonna look at it and I can see the grain sizes. They're definitely visible, right? And I can see that there's a bunch of different sizes here. Like, not everything is the same size. All right, and I'm going to take a look over here at my rock identification chart, right? Rock fragments and or quartz grains, feldspar grains, etc. All right, and I'm going to use these pictures as a really good kind of aid to help me identify the rock. So if I take a look over here at the coarse grained rocks, I have a couple of different choices here. One, I notice that this rock on the top, I can see that the grains are angular. All right, and if I look at the one at the bottom, I can see that the grains are rounded. So I want to take a look at my sample, all right, and see All right. I see that a lot of these are pretty much angular. All right. And why don't we get another example? If we take a look at that one, we can see that one, it's very poorly sorted, so there's a lot of different size sediment in there. And the grains themselves, you can see that they're rounded. All right, over there, there's another one. Over here, all right, it's definitely rounded. All right. If I take a look at the next part, all right, is really identifying the size, gravel size we talk about. So it's larger than 2 millimeters. And I can see that both of these sediment sizes, for the most part, are larger than 2 millimeters. If it's angular, if most of the sediment is angular and jagged, I call that breccia. If most of the sediment inside the rock is rounded, also larger than 2 millimeters, then I call it conglomerate.
Okay, so let's move on to the different grain size. Let's move down in size to the sand size grains. And we can get some of the sand size grains off our paper. That would be good. So when we're thinking about sand size grains, we're going to go from a coarse sand that may be very quartz rich, it may be a pure quartz sand,
Sure.
all the way down to a finer quartz sand that may even be mixed with some clay. So we're going to have several different kinds of sand-sized grains in sedimentary rocks, and they're all going to fall into the category of a sandstone. That makes it easy. So we're going to put a couple of these pieces of sandstone here and see if we can see some of the differences between them. So I'm going to put 4 pieces out, and I'm going to look at the characteristics of them. The first one you can see is very white in color, and if you rub your fingers across it, you'll feel the sand grains, and you can actually rub some of those grains off on your hand. If you take this rock and you look at it under a microscope, you will see that these are beautiful, clear quartz grains, and they're held together with a nice quartz cement. So we're going to pretty much think this is a quartz sandstone.
Got it.
Quartz-sized grains, quartz sand composition, quartz sandstone. Looks very different from this particular rock. This is a little bit coarser size grain. If you rub your fingers across it, you feel that it's rougher. Yeah,
sure.
It's rougher. And if you inspect it with a microscope or a lens, you'll see that there are some little reddish grains of feldspar in here. There are also some grains of mica here. But there are also some quartz sand grains in there. So this is a sandstone because it has sand-sized grains, but it's a special kind of a sandstone that we're going to call an arkose. And it's an arkose because the composition of the grains themselves is not pure quartz.
Got it.
It's a mixed variety of minerals with some feldspar mixed in with it. So arkose is a feldspar and other minerals in a sand-sized grain.
Got it.
We're going to take a look at this gray color sandstone. Again, we can rub our finger across it. It feels very gritty. We can see some of the bedding plane here, some of the layering in the sand grains. And if we looked at this under a microscope, we would see some very fine particles of clay mixed in with the quartz sand. So when you see this gray color sandstone and there's some clay involved in it, then we're going to have sand mixed with clay mud or a gray wacky sandstone.
And they're all sandstone, all of the samples that we just went through.
One more that we have out here that can be a little bit confusing, that one or this one, and we'll look at some other ones maybe later, are also quartz sandstones, but these are held together with a cement that's rich in iron from oxidation. So thinking back to weathering, still a quartz sandstone, just cemented together with some iron oxide.
Yeah.
Okay, so those are our sandstones.
All right. And then we're going to move on to the next grain size smaller, coming down the list over here. right? And what's really interesting about these is that if I actually were to touch sandstone, it would just feel like sandpaper, right? And if I touch something that's a little bit smaller, I would expect it to feel a little bit smoother than the sandstone. So we have this, which if I take a look and I feel it, it definitely feels a lot smoother, all right, than it did with the sandstone. So I know that it's smaller than sand, and I'm starting to get into more of my mudstones. It's just a smaller size sediment. All right, this one here, right, is mostly made up of silt. All right, and I refer to that as a siltstone. This one. All right, this guy. If I were to compare how this one felt compared to this one is even smoother, telling me that it's even smaller than what this one is, and considerably smaller than the sandstone. All right? And I go down over here that I think it's smaller, all right? And I go to the next smallest that it's mostly made up of clay-sized particles, and I would call this shale. All right. It also tells me that it easily breaks into layers, and if I were to take a look at the side, if you could get that, Mr. Baldwin, you could see the layers in the rock. Right.
Hey, Mr. Z,
yeah.
Shale always that black color?
No.
Ah, so shale can actually be other colors. You can have a gray shale, you can have a rusty red color shale.
Sure.
How about siltstone? Is it always that color?
No.
Can it have different colors of that as
well?
well?
Of course it can.
Okay. So we've got different sandstones.
That can be different colors.
Different siltstones, different shales, and conglomerates that are made up of really poorly sorted rock.
Sure.
So the conglomerate and the breccia would be poorly sorted.
Yeah.
The sandstones, the siltstones, and the shales are all well sorted. Okay. Good.
Because they're all the same size.
All right, so I think that kind of wraps up our clastic or detrital sedimentary rocks. And you have a quiz on this in your class webpage, so jump on, take that, and we will see you in class tomorrow ready to roll on these.
All right, good luck, everybody.
Bye, guys.